I started using ChatGPT almost immediately after its release, but half a year ago I decided to cancel my ChatGPT Plus subscription because I realized that I trust too much a company that has troubles defining what open and safe AI actually means. I also realized that I've uploaded private documents, like for example my rental contract, to the system that was under a constant attention of hackers. And then I was not happy with the ever-growing tendency to adjust LLM output so that it suits better the current political agenda. I didn't like the idea of a blacklist of forbidden phrases, because in fact it reminded me of the country I was born in. That is why I decided to run my own ChatGPT-like setup on my own hardware using exclusively open-source software. So I've spent 820 euros to build a home server with 384 GB of RAM, 40 CPU cores and 2 NVIDIA cards, each with 16 GB of VRAM on board. Once the gear was up and running on my storage shelf, I also cancelled Midjourney subscription because good people, open source GenAI tools you can download and install free of charge are simply outstanding. I will show you now how exactly my server setup looks like and how I use it. I will share with you which LLM models I use for my day-to-day work and why, what multimodal workflows I use, how I integrate web search into my chat interface, how I do simple reg, that is query LLMs on my local documents, how I work with graphical content, and what are my processes for text-to-image and image-to-text generation. The LLM part of my setup you can even replicate on your laptop without a discrete GPU card. No overcapacity error messages anymore. But first, a disclaimer. I'm not a generative AI expert, so everything I share here comes from the point of view of a guy that is more on the user side of GenAI rather than from a point of view of someone who trains or fine-tunes ML models. I use GenAI as a sysadmin, developer, and researcher. However, if you are my subscriber, you probably know that I try to get to the bottom of things I'm talking about. So after watching this video, you will understand the terminology and basic principles behind current GenAI solutions, which means you will be able to read or watch specialized tutorials and understand what's going on there. In addition to that, you will be able to configure and use tools like those I show in this video or their alternatives. To run a local ChatGPT-like service, I use two open-source products, Ollama as a backend and OpenWebUI as a frontend. Ollama is a bit like Docker for LLM models. It allows you to pull different models and then query them using a command line or an HTTP API. Here's how you can install Ollama. Side note, all the software mentioned in this episode that uses GPU by definition requires proper drivers. For NVIDIA cards, you need to install CUDA drivers. CUDA drivers basically allow you to use NVIDIA GPUs not for rendering graphics, but for parallel computations, which is the bread and butter of GenAI. To make sure that NVIDIA drivers are in place, you can use NVIDIA SMI tool. And to verify that Ollama works properly, you can query a smaller model with a run command. Just like with Docker, run command will pull the model and then load it. This is the command line chat interface. Not very useful outside some basic use cases, but actually perfect for this kind of smoke testing. Obviously, for this demo I memorized the exact model name I wanted to install. But normally, to find LLM models supported by Ollama, you browse the Docker Hub of LLM models, the Ollama library. I always choose newest here in the drop-down on the right, because what's the point in having all this variety if not trying new stuff? I check the library from time to time for new models to download and experiment with. Let's say I'm checking Qwen 2.5 Coder. There's a lot of information on this model page. If you click here, you can see a bunch of different variants of this model. These numbers with the letter B after them mean how many billion parameters each of these variants has. For example, here the biggest Qwen 2.5 Coder model has 32 billion parameters. Generally, the more parameters, the more knowledge, roughly speaking, the model absorbed during training. The number opposite the parameters number is the size the model will occupy on your disk when downloaded. Now, if you want to know how much video memory a particular model variant needs and what is quantization, check out the link to the bonus video. Okay, what would be the proper question to ask this model? The model page highlights that Qwen 2.5 Coder is good, well, it should be obvious from its name, for code generation, code repair, and code reasoning. So let me ask it a question that is suggested by yet another prompt engineering website. This is how unquantized model performs. Notice that Ollama can work with a model that is partially loaded in GPU memory and partially in RAM. You can also see that token generation, that is, generation of an answer, is much slower than if a model would be loaded completely in GPU memory. You won't see a massive difference in the quality of response of a full model in this particular case. I would love for Ollama models to have versions, because I can absolutely imagine a certain model becoming worse after an update, if only by applying new filtering rules, for example. But for some reason there is only the latest version stored in Ollama library. So I've made peace with the situation and configured a cron job to pull updated models daily, knowing that older versions will be gone forever. Most models update quite frequently, by the way. Okay, this Ollama CLI is good enough for testing models, but in my daily work I use a proper web frontend which is called OpenWebUI. It is a one-man project, and you will see in a moment that this guy who develops OpenWebUI simply rocks, because OpenWebUI is everything good you have in ChatGPT interface, plus all the features you always wanted to have there but never really got. To run OpenWebUI you need Docker. Notice I'm setting WebUI auth environment variable to false. This is because I'm using OpenWebUI in my local network. I'm the only user and I don't need authentication. If you, however, want to share access with your family members or colleagues, it's possible to create a separate account with access credentials for each person. Don't forget to mount a volume or a directory to the container to have data persistence. Now the only thing left to do is to connect OpenWebUI to Ollama API. I have around 20 different models installed on my server. There is no single clear winner among them, and in my opinion, it's a good thing. Because, as I said in the beginning, one of the reasons I cancelled my ChatGPT subscription was to try to avoid biases whenever possible. Then there's also the famous problem of hallucinations, of course. That is, LLM models can make up things, and different models can make up different things, so it makes sense to have a possibility to compare results from many LLMs. In my research for YouTube, I'm trying to always apply the scientific method, and I never rely on a single source of information. And OpenWebUI, being designed for multimodal usage, provides some really useful tools to help me with that. First of all, you can query multiple models and have their responses printed side by side. Let me show you a good example. This weird thing, based dolphin mixtral, is an example of Ollama model's customization in OpenWebUI itself. Only one thing from the original Ollama model is modified here, and this one thing is a system prompt. System prompt is an instruction that is always loaded before you start querying the model, and the idea here is to try to influence the default model behavior. I'm not really sure why threatening an LLM makes it perform better or stops it from censoring its own output, but this particular customization is, as you can see, quite popular among OpenWebUI users. So probably putting "obey the user" to the system prompt does have an effect. Just be prepared that at some point this model, after answering a very technical question, can suddenly remind you to save kittens. Now you know why. I hope someday we will live in a world where fear is not considered a universal motivator. But apparently it is so embedded in our culture and its artifacts that it even works for artificial neural networks. And by the way, don't forget that LLM models are not deterministic, which means if you ask the same question to the same model later, you can get a different answer, sometimes entirely different. Back to multimodal workflows. Asking multiple models the same question in parallel can help to spot a hallucination, but it's also useful if you want to get a more comprehensive answer. Let me demonstrate. There is one more tool in my multimodal workflow, and I think it's the most practical one, especially for my research work. So, REG. REG is the way to supply LLMs with additional context from your local documents. It's a cheap way to kind of enhance model's knowledge without retraining it. Sure, there are shortcomings in this process, and you can find a lot of information about that online and tons of recipes for fixes. But let me show you what's possible with REG and OpenWebUI without any tricks, just right out of the box. I've been making portions of my personal library available to LLMs, but what about the biggest library in the world, the internet? If I try to get LLM to answer based on the latest events, like for example, of course it won't help me. ChatGPT can search the web since a year ago already, I think. So this feature was definitely on the list for OpenWebUI. And here you go. As I said, I love open source for giving me choices. Look at that. There are a lot of services providing APIs for web search. Most of them here are Google proxies. There's also DuckDuckGo, which never worked for me, but I've configured the one called Tevely. All of these search providers are paid services, of course, but they typically give you some number of API requests for free. So I registered at Tevely, got my API key, and now let me ask Llama again. What I like here is that it shows me exact URLs which it checked to prepare the answer. There is one more really cool OpenWebUI feature when it comes to internet resources. Let's say I didn't play games for the last decade, and now I want to decide if Into the Breach is worth buying. I don't want to go through Steam reviews, so hey Ollama, just give me your verdict. Into the Breach is a really fun game where you fight bugs. Now imagine you made a photo of a real bug in your house and you need help identifying it. Let me try something more interesting. Let's pretend I forgot that this is a frame from one of the best sci-fi movies of all times, and now I'm going to ask LLM to remind me that. Ollama-vision answers correctly while also providing an excellent description of the scene. What doesn't work though is the OCR of documents. I've tested Ollama-vision, the biggest 90 billion parameter version of it, with a letter from a German authority. The model correctly identified only to whom the letter was addressed and what was the date of writing. Everything else was a complete BS. I mean, hallucination. Naya. And finally, good people, an OpenWebUI feature that is so obvious yet for some reason is still missing in ChatGPT: folders. OpenWebUI and Ollama are my daily drivers. When I was working on this episode, I did a number of tests of my installed models to formally evaluate them. I didn't use any questions about strawberries or fractional numbers because that's not how I use LLMs. Instead, I've taken a couple of real technical questions I came up with lately and a good old sysadmin riddle, and then compared answers to them from all the models I have. The first question was about a very specific use case of a Python package manager poetry, and not a single model gave me a correct answer. All of them very heavily hallucinated. Only Codestral, which is a code-focused model from Mistral, surprised me. It answered without sliding into making things up. It looked like an answer from a person who didn't have access to up-to-date poetry documentation but had common sense and a general understanding of how Python packaging works. By the way, if you want to beat LLM models in fundamental Python packaging knowledge, I have an in-depth video which explains how and why Python package managers work the way they work. Next question I used for testing was a code generation question, in which I asked my LLM models to write Terraform code. Terraform is a popular infrastructure as code tool that is used to manage cloud resources. When working with Terraform, you have to write code in its own DSL called HCL. Only 3 models among my 20 generated syntactically correct Terraform code: Nemotron, Dolphin Mixtral, and YCoder. Both YCoder and Dolphin Mixtral did not provide Python script for a Lambda function, which means they did not follow my instructions completely. Nemotron, which is Llama 3.1 fine-tuned by NVIDIA, actually wrote that Python code in a commented region of the Terraform code, supplying it with a good explanation on where to put that code for cloud deployment. All 3 winner models provided a no BS text surrounding the code. At the same time, all the other models not only generated Terraform code with errors, were hallucinating, but also their explanations often were in fact just extended variations of my query. Terraform code that came out of AI Expanse model was a champion on syntax errors. There were 8 of them, and the median was 1 error. My last test question was an old sysadmin riddle. Now, this question, of course, requires some degree of what they now call reasoning. Using broken chmod to fix broken chmod should not, obviously, be used as an answer to the riddle. But more than a half of my 20 models suggested exactly that, often among other options, some of them sensible, some not. Only the reflection model explicitly said that chmod cannot be used because it's broken. But reflection is a bit of a special case. It's slow, but it always applies the chain of thought approach when answering. Basically, it writes an answer and then reflects on it out loud, criticizes its own output and tries to improve it. So I expected this model to be somewhat better with reasoning. It still suggested one wrong fix and one correct fix to the problem, by the way. Other models that did not suggest using broken chmod, and I'm not entirely sure if that happened just out of randomness, these models still proposed lots of stupid things to fix chmod, and only one model really shined in this test. Well, compared to other models, of course. It was Qwen 2.5 coder with 32 billion parameters. It answered with 3 correct and 2 wrong fixes. By the way, the answer of the same model was an absolute disaster. Unrelated to these 3 test cases, I can tell you that very small models, Llama 3.2 and Gamma 2 with 2 billion parameters, were often hallucinating on many different technical questions. Though maybe these smaller models need more context provided in queries by default. If you worked with smaller LLM models, please share your experience in comments below. I use them for summarizing or text rewriting tasks only. Another interesting finding I'd like to share is about CodeLlama. This model once, out of the blue, literally lectured me on respect, inclusivity, and empathy when I asked it to continue a sentence on image generation models' differences. Maybe AI inclusivity is the new trend at Meta. I don't know. Anyway, the answer to the question which LLM models I use and why will probably not surprise you if you've watched up to this point. The thing is, I do not have a favorite model or a bunch of models I always prefer to use. I've shown you before how to work with multiple models, and in my opinion, this is undoubtedly the most powerful feature of open source LLM tools. So instead of finding the best performing models for my use cases, I make a conscious effort not to stick with the same models for long and always experiment. The only preference I have when I don't have time for a bigger model to pour answers drop by drop, I tend to pick models that fit in my GPU card's memory. For my setup, these are Qwen 2.5 coder models, Aya models, and Dolphin Mixtral. OpenWebUI has a very intriguing concept of functions. These are Python scripts that can pre- or post-process your interactions with LLM models. For example, there are functions that work as model routers. This means that if you ask a code question, they can pass your question to a model like Qwen Coder if you upload a picture to something like ollama-vision, and so on. Or you can build a pipeline where output from one model is passed as an input to another. I think such functionality in an easy-to-deploy packaging is a very powerful tool. But unfortunately, all the functions that I wanted to show you didn't work the way I expected, or I just could not figure out how to use them. I attribute that to version incompatibilities between functions and OpenWebUI, which are obviously the project's growth pains, and I think it will get better with time. Of course, if you know Python, you can write your own OpenWebUI functions. And if you want to become really confident with your Python skills, get experience working on complex projects, and then stand out in the crowd where everyone uses LLM, try CodeCrafters. Click on the link below the video, register, and pick the Python track. With CodeCrafters, you can build, step by step, your very own Redis server, your own Kafka, your own shell. You got to choose from many different options. By subscribing to CodeCrafters with my referral link in the video description, you will also support my work for this channel. My friend, who is a beginner Linux user, once asked me, why there simply isn't the one single Linux distro where everything just works? It took me a moment to answer, and then I said, because Linux is not about something that just works all the time. It's about something that you can understand and try to fix. Sometimes, instead of an answer to my question, I'm getting an error message in OpenWebUI. This is when I have to go check Ollama logs to find out that the model failed to reply because of some CUDA error. Sometimes models just do not unload and do not free VRAM for the reason unknown. The only working cure for these issues for me so far was the Ollama daemon restart. These hurdles can be frustrating for sure, but as I said, both Ollama and OpenWebUI are very actively developed, so I'm sure that with the right mindset, your interaction with them will be an interesting and pleasant adventure. This is InvokeAI. It's the OpenWebUI of text-to-image generative models, or in simple words, it is the interface that allows you to write prompts that generate images. And this is how its installation process looks like on Linux. There is an enormous number of image generation models on Hugging Face. Thankfully, you don't have to sift through this gigantic list because InvokeAI provides 3 so-called model starter packs. They are split by corresponding base models. SD1.x starter pack is for the Stable Diffusion model version 1.5 and its derivatives. It is the model that started it all. In August 2022, an open-source competitor to commercial image generators DALL-E and Midjourney appeared on the scene. It was fast, it could run even on the cheapest gaming video cards. The results were comparable to closed models, but most importantly, you could do with it whatever you wanted. People started fine-tuning Stable Diffusion, and this is how thousands of derivative models were created for many different use cases, from medical research to anime, and of course, you can imagine which content generation. The original Stable Diffusion still has a huge community following. SDXL is exactly what its name suggests. It's the model of the same architecture, but everything is bigger there. Its neural network, its base image resolution, and its video memory requirements as well. And FLUX is a new and an entirely different beast that feels more modern. It understands prompts much better than earlier models. Instead of writing a bunch of comma-separated features, you can describe the picture you want to see the way you would describe it to a fellow human being. The downside is that FLUX is much slower than Stable Diffusion, at least on my 2 10-year-old NVIDIA cards. So if I need something generated by FLUX, I push several jobs to the queue and go read my X feed. By the way, follow me on X for extra content on topics that I cover on YouTube. Stable diffusion models are generally not good with typography, which means that if you want to add text to your picture, you can end up with something like this. Now, if you scroll through the models included in Startup X, you will notice that there are these gray boxes in front of model names. Main obviously means a model you will query to generate an image. For example, in SDXL Startup X, there are fine-tuned Stable Diffusion XL models called Juggernaut, with a focus on photography and architecture, which is made to generate better images with buildings. Main models are also often called checkpoints. You always select only one main model in InvokeAI interface before you run image generation. Then there are more different types of models, and the reason why you have all this variety is because when you generate an image, it's actually a concert of models that is doing the work. For example, you always have a VAE. It's a neural network that creates a representation of an image in a so-called latent space. It's roughly the same process your brain does when you, for example, read Lord of the Rings and you imagine Gollum. Your mind is not drawing a perfect picture with all the details. Instead, it holds on to the most important features of Gollum: big eyes, bald head, clingy long hands, and very thin body. The result is like a super compressed sketch of the real Gollum that you could see in Peter Jackson's movies. Just by keeping that sketch with your internal sight, you can now even draw a picture of Gollum, if you know how to draw, of course. And you do that drawing by decompressing the sketch in your mind into curves on paper. Now let's say you've put the Lord of the Rings book to the side and started watching some of the Ghibli Studios animes on Netflix. And at some point a brilliant idea darts through your mind. How would Gollum look like in anime? Your mind sketch of that creature in an instant turns into something with an exaggerated facial expression, green hair, and an explosion-like haircut. This process your brain just performed in the world of images generation is called style transfer, and this is what these VAE models are good for. And they do this style transfer by modifying a compressed representation, which is, as I said, called the latent space. In practice, a custom VAE may or may not improve certain finer details of a generated image. It may or may not make the image look crispier. You have to test by yourself to decide if a custom VAE benefits for your specific use case. What almost guarantees you more control over the image generation process are the next two model types. Because if you ever try to generate images, you probably know that sometimes it can be rather hard to make the model draw exactly what you want. Let's say you want to see just one person, but instead you get two doppelgangers. It gets especially challenging when you want the person to be in a certain pose or face a certain direction. And this is where ControlNet and IP adapter models come into play. They can use an already existing picture to guide the generation process. ControlNet models work by detecting the structure of an input image, so they generate something like this from a sketch like this. and IP adapters convert your input picture back to a prompt tailored to a certain main model. IP adapters detect features of an input image, which means that instead of telling the main model what to do, you can show it what to do. But what if even these instructions do not help to make the main model draw a certain detail or a scene? Then you probably need LoRAs. LoRAs, or concept adapters, are like patches for base models. Instead of fine-tuning a whole base model, which is a time and resource-demanding process, it's possible to teach it a new concept on just a handful of images. For example, how to draw a polka dot dress, steampunk buildings, or human hands. By the way, this is how all these AI business headshot generators probably work. You can enable several LoRA models in your InvokeAI interface. In many cases, you also need to add a trigger word or a phrase to the prompt to make the LoRA model do its thing. Now that you know what are the main types of models you may need to use when working with InvokeAI, let me show you my image generation workflow. When I want to generate an image from scratch, I start on CivitAI. To find an inspiration, I search there for images in the style I want. When something particular stands out, I click on the picture and look at the generation data. I can just copy positive and negative prompts from there. Negative prompt is, as you may have guessed, for things you don't want to see on the generated image, and by the way, there is no need for negative prompts for FLUX models. Just copying prompts may be a good starting point, but sometimes I would need to get the fine-tuned models or LoRAs as well. The way I do that is by clicking a link here in Resources Used section, then clicking on Download button on the model page. This will obviously put the model file on my local machine. What I do next is I simply copy the model file to my server, to the so-called scan folder configured in InvokeAI. And then by a click of a button, the new model is added to InvokeAI toolbox. LoRAs, as I said, often require triggers. When I download a LoRA model from CivitAI, I also copy trigger words to my note-taking app, because the model author can decide to remove the model page from CivitAI later on. If you actually only have a model file, you can still try to get trigger words. This snippet I found on Stack Overflow will work if metadata was stored in a model file. Okay, once I've copied everything I need from the reference pictures page, I start playing around with InvokeAI by tweaking prompts and model parameters until I get the result I like. Sometimes a seemingly unrelated change in the prompt can lead to an interesting result. And overall, the process looks more like alchemy and play rather than science and art, but it's certainly something I can enjoy. Good people, as you can see, overall the possibilities for tinkering with open source GenAI tools are mind-blowing, and despite some annoying bugs, which I'm sure will be fixed soon, they are very much capable of replacing subscription-based services, especially if you value privacy and don't want to put up with censorship. Thank you for watching, and see you next time! For example, you always have a QWeb, блять, муха ебучая.